This video is actually part 2 of demonstrating how to complete lesson 3.4 in our 6th grade Carnegie Math Student Assignments book. The item that we're working on is this one. It goes along with number 16 and 17. It can be found on page 31. I will read the information that they start us with and then look at what they require of us to answer the items correctly. A school participates in a reading contest. The table shows each 6th grade class's portion of the grade's total reading minutes. Use benchmark fractions to help you order the classes from the greatest number of reading minutes to the least. Explain your reasoning. Let's look at the data that they present to us in this table. Mr. Hall's class has read 5/12 of the reading minutes. Mr. Cornett's class has read 1/18. Mrs. Smith's class has read 4/9, and Miss Earl's class has read 1/12. Now, in order to use our benchmark fractions, I guess we should go ahead and figure out which benchmark fraction, whether that be 0, half, or a whole, with the portions that they provide us. Then we can decide which one is the greatest value and which one is the least. Now, when I look at these fractions, and I want to use benchmarks for that, I'm going to just for now just put a little I'll put a little number line right here, and I'll say that this point here is very close to 0, this point here is close to the whole, and this point here, not drawn to scale of course, will be where we'll put half. So 0, 1/2, and then our whole. Now 5/12. 5/12 could be found on our number line right about here. I'm going to say it will go here. 5/10 will be exactly half, but 5/12 will be just a little bit less than half. So I'm going to put 5/12 right here. Now 1/18. 1/18 is very close to 0. 1/18 would be right around here somewhere. Now, of course, these are not drawn to scale whatsoever, but to give you an idea of where they are, what benchmark fractions they're close to, I'll go ahead and put 1/18 right here. Now, 4/9. With 4/9, that's almost half also. When you have 4/9, if you had 4/8, that'd be exactly half. 4/9 is very, very close to half, but not exactly. Now, in my line of thinking, I'm going to put 4/9 right here. And the reason I'm putting it closer to half than 5/12 is 9 parts is a fewer number of possible parts than 12. And if I have 4 of those parts, then I really have a little bit more closer to half than 5/12 would be. So I'm going to put 4/9 right here. And 1/12. It's very close to 0, but it's not as close to 0 as 1/18. I'm going to go ahead and I'm going to put 1/12 right about here because there are fewer parts, 12 perhaps. One of them would still be a larger portion than 1/18. 1/18 would be even tinier. So this is where we could find these fractions on a number line. We would find 1/18 and 1/12 close to 0. We would find 5/12 and 4/9 close to half. So we can say that both 1/18 and 1/2 are close to 0. When dividing a whole into 18 equal parts, the parts are smaller than when dividing a whole into 12 equal parts like I just said. This means that 1/18 is less than half, and then both 12 and 4/9 are close to but less than half. But because 5 is actually farther away from half of 12 than 4 is from half of 9, 5/12 is less than 4/9. So the classes ordered from the greatest number of reading minutes to the least are In this case, we could say Mr. Cornitz, then Ms. Hurls, and then Mr. Hall's, and finally Miss Smith's class. Now, I went through that pretty quickly, the explanation, so I think I'll go ahead and post this here so you can see what that would look like. And that rooster you just heard in the background is a pet of my daughter's, part of her 4-H project from earlier this year. So to reiterate our response and explanation, both 1/18 and 1/12 are close to 0. When dividing a whole into 18 equal parts, the parts are smaller than when dividing a whole into 12 equal parts. This means 1/18 is less than 1/12. Both 5/12 and 4/9 are close to but less than 1/2, because 5 is farther away from half of 12 than 4 is from half of 9. 5/12 is less than 4/9. So, the classes ordered from the greatest number of reading minutes to the least are Miss Smith's class, Mr. Hall's class, Miss Hurl's class, and Mr. Cornett's class. Now, we used 3 of our benchmark fractions just a moment ago. We used the benchmark fractions, and I'm going to go ahead and draw another number line up here. Then we'll talk about potentially some more benchmark fractions. But so far, we use 0, which will be placed about here. We use the whole, which we'll say around about here. And then we'll put a half right there. So we have 0 here, 1/2 here, and we have a whole here. Now, what about other potential benchmark fractions that could fall between 1 and 0? If you've ever looked at a ruler, they have other benchmarks besides a 1/2 inch or a whole inch or 0. If you've ever looked at a measuring cup, you'll have perhaps a 1/2 cup and a whole cup. There's other benchmarks that are very common, and before I reveal those, let's imagine what would go here. That's the common benchmark area, and right here. What would be a benchmark fraction for here and for here? Think about it for just a moment. Okay, between 0 and 1/2, there is the fraction 1/4. Between 1/2 and a whole, there is the benchmark 3/4. Think of it this way: 0, 1/4, 2/4, which would reduce to 1/2, and then 3/4, and then 4/4, which could actually be 1, or the whole. So some other common benchmark fractions that we use all the time in the real world are 1/4 inch and 3/4 of an inch. Later on, we'll be doing some more work that will have us utilizing not just the 3 benchmarks that we've been using, 0, 1/2, and 1, but also these 2 benchmark fractions, 1/4 and 3/4. Thanks for watching.